All right. So, Tony, thank you very much for joining us today. Today is episode 7 of Curtain Wall Conversations, and we're very fortunate to be joined by Tony Crimi. Tony serves as the chair. This will be long, so patient with me, Tony. You're a busy guy. Tony serves as the chair of the National Building Code of Canada Standing Committee on Fire Protection and the Ontario Building Code Conservation Advisory Council, as well as serving as a distinguished member of the International Codes Council, National Fire Protection Association, Society of Fire Protection Engineers, and much more, for which his contributions have garnered him several notable awards. And if that weren't enough, Tony is also the president of AC Consulting Solutions Incorporated, where he assists companies in navigating the regulatory landscape. He specializes in providing services related to building and fire protection codes and standards, including assisting clients in achieving successful testing and product approval and recognition from regulatory authorities, advocating for U.S. code and standard changes, researching product and regulatory information, and facilitating product testing and evaluation. It's been a privilege for all of us on the GlasCurtain team to work with Tony over the last couple of years on the NFPA 285 certification, in particular for our new ThermaFrame fiberglass framed curtain wall system, which we successfully completed in September 2022, and which opens the door for ThermaFrame to be used on non-combustible buildings in the US market. That was long, so thank you for bearing with us. Tony, welcome to Curtain Wall Conversations.
Thank you very much. It's a pleasure to be here. And yes, it was a long introduction. I think that says I'm getting old.
Well, that's a life well lived. A life well lived. So let's start with a little bit of background, Tony. Maybe you could tell us a little bit about how you started and how you became interested in particular in codes and standard development.
It's interesting, like most things, I guess these things sort of evolve organically. I graduated, got my master's degree from the University of Toronto many years ago. And my first job was at Underwriters Laboratories of Canada. Of course, ULC being a certification body, a testing body, but also standards development organization, gave me a little bit of the opportunity to get a sense of what that meant. As I started there and started to be one of the users of the standards and trying to conduct the testing and interpret what the requirements were, I realized that, number one, it can be challenging. And secondly, that particularly as new technologies evolved, there was a need and an opportunity to do something creative. I've always had an interest in research and development, in business development. And so surprisingly, maybe even to my surprise, the sort of codes and standards world actually integrates quite well with that, both in terms of providing limitations, but also opportunities. So that's kind of where I started.
On your journey, you've chaired various advisory councils related to building and fire protection codes and standards in your sort of career. What do you feel, looking back a little bit, of course, also looking forward, what do you feel so far, at least, have been some of the most significant changes or improvements that you've been involved in implementing?
Well, it's interesting because there have been a lot of different things, and over the years, in many cases, they're kind of incremental. I think if we kind of look at the areas that you're involved with, particularly in the early days when I got involved with the National Building Code, for example, the current test that we use, S134, didn't exist.
Sorry, what was the history? For what year would that have been? When was S134 implemented? It kind of just seems so normal now. It seems like such a sort of fixed part of the landscape, but of course it wasn't always so.
In fact, that in the early 1990s, and I believe it was the 1990 edition of the code, or it might have been the 95 edition, NRC had conducted the research on the development of S134. It was discussed, but there was no standard at that time. So the test method in, I think it was the 90 or 95 code, was written into the code, more or less over several pages. Once there was an agreement that that was a method that we wanted to pursue nationally, we started an activity at ULC to develop the S134 standard and ultimately shorten the code a little bit by adding the reference, but also the maintenance, obviously, with standards. That's the other feature.
The timing of when that was being implemented, what were some of the motivating forces? What was some of the rationales, the logics of the moment, if we, rewind 30, 35 years to that time?
A couple of things where the market had started to shift. One was the introduction of foam plastics and exterior walls. And particularly at that time, it was each systems that were really just beginning to evolve into the marketplace. Concurrent with that, there had been a fire in a parking garage in Winnipeg, Manitoba, where the building had been clad with each systems at that time. There had been a fire at an underground parking garage. NRC had been involved also in an investigation as to what the cause of the fire was, what caused the fire to grow. Now, obviously, it was a parking garage underneath the building, so the significant fuel source. And so that kind of identified, at least in Canada, the need to do a better job of adding requirements and performance levels, expectations for the evolving technologies.
Interesting. Yeah, I mean, that's somewhat reminiscent of, sadly, Grenfell in London. What was that, 5-7 years ago now? And, my understanding was that there wasn't such a code in the UK. And I don't know if this is kind of a severe enough event to precipitate those kind of code changes. But I didn't know that part of history, actually, that a Winnipeg parking garage fire was, the kind of Canadian equivalent, 30, 40 years ago.
The UK and a lot of Europe depends much more so on performance-based requirements. They've really always, for a long time, gravitated away from prescriptive requirements towards performance requirements. The challenge with that is you can also go too far. If you look at their building regulation, it's essentially one sentence that says, you have to construct the exterior cladding so that it doesn't burn up the building. Now, having said that, that's the regulation. They do have quite extensive guidance documents that give you a lot of information on how to achieve that. They're not mandatory documents.
They're enforceable.
Correct. And so the design community, construction community has a lot of flexibility in terms of how they actually determine and decide that something meets the performance requirements of the code. In Canada, when we had those conversations about performance-based codes, as you know, we ultimately went to objective-based codes.
Just happened to come back from Europe for people who, whether they've been to Europe or just love Europe and the idea of it, look at images online, just to play devil's advocate. Is that why European buildings are more attractive? Is that why they're more beautiful? Is that they have more design flexibility and less prescriptive, objective, quote unquote, regulation?
It may well be. It provides a greater level of flexibility. The challenge is it relies very heavily on knowledge, experience, and data, availability of data. Usually what gets reported and published are the successful tests. What doesn't get reported or published are the unsuccessful tests. And there's a good sized pile of those.
We actually attempted CAN ULCS 134. It probably would have been in 2010 or 2011, probably 2010, actually. That was when Underwriters Laboratory still had a facility outside of Ottawa. NRC, still had a facility outside of Ottawa for that test before Intertek, sort of ran away with the monopoly for the continent. And we were unsuccessful in that test. And it took, almost 7 years for us to, frankly, just get the funding to do it again. And it turns out the reason we failed it the first time was that, never having done this test before, there was a small gap between where the assembly was and where the fire started. And that little air gap allowed the fire to sort of get in behind the assembly where it's not supposed to test, right? The fire is not supposed to test the inside of the facade. It's supposed to test the outside of the facade. We didn't know. And of course, NRC and UL and, the testing authority can't tell you that while you're setting up. And we didn't have a Tony Crimi, to help, point us and say, hey, Pete, hey, you guys maybe should, just move this an inch. And so when we retested in 2017, 2018, all we did was we changed it and moved it an inch and we passed, because the system itself, we know, has absolutely the capability to pass the test if you install it correctly. And, that's a good object lesson in the field in general. Right? That you can design the best curtain wall system, you can design the best whatever product in the world. If it's installed poorly, it's not going to perform very well.
And you learned a lot, even just from that experience. There's a lot learned a lot more learned, actually, in many cases, from the unsuccessful ones.
The saying, I don't remember where I first heard it, but it's that you either win or you learn.
Yes.
Right? It's like those failures are educational. Exterior flame spread test versus, other understandings of, combustibility. How do you define combustibility?
So this is an interesting question for a lot of reasons. And partly it's because of the market perception versus the code requirement. Combustibility and non-combustibility are the two sort of yin and yang of this conversation, right? It's easier to focus in terms of explaining this on the non-combust So then let's ask the question the other way. What would be non-combustible? What's non-combustibility? One thing people seem to misinterpret is that non-combustibility is a property that we measure in a very specific way. You can't make, for example, a plastic material non-combustible by adding flame retardants or by adding fillers. That's not the way non-combustibility is defined. Non-combustibility is literally defined in the Canadian codes by reference to a test method, which is CANUL CS114. That is a 1.5 inch by 1.5 inch by 1 inch cube that we immerse in the middle of a tubular furnace at 750 degrees. And we measure temperature rise at a very stringent level, 35 degrees C maximum. We measure weight loss, and we look for flaming. That is the primary way of defining something as non-combustible. Your earlier question was one of the other things that I've been involved in code development, and one of them was chairing a task group to develop an alternative to that method, which is based on the cone calorimeter test. It's CANUL CS135, and you'll notice in the code that it provides you another option for establishing non-combustibility of not just materials in this case, but potentially laminates and systems. One of the drawbacks of the traditional non-combustibility test, which is very similar to what's used in the US, is that, first of all, it's for virtually homogeneous materials. You can't do layered products or anything of that nature with it. And it's also a pass-fail. It's either it is or it isn't, which is also potentially problematic because, as I say a lot of times in presentations, there's no distinction between something that, exceeds the criteria by 2 degrees and jet fuel. They're both in the same category. They're both combustible by definition. One of the things I think is important is to understand too for the marketplace that what things like flame retardants and fillers can do is reduce flame spread. And that's sort of another whole category of performance. So in buildings, we start with a premise that buildings either are combustible or non-combustible. Well, I should say either combustible construction or non-combustible construction. Now, of course, we've added EMT in this current edition of the code being encapsulated mass timber, which is a really interesting and big shift forward to have a third type of construction in our code. But traditionally, it's been combustible construction and non-combustible construction. And then non-combustible construction essentially has a series of allowances for combustible materials based on things like reaction to fire, that being flame spread testing and things of that nature. And then fire resistance, which is another category, which is more based on, certainly based on assemblies, but also looking at separation of areas, whether it's a floor or a wall or things of that nature. So sort of a hierarchy as we progress through the code.
S101 is one that we get asked about as well. Where does that fit in?
S101 is the standard for determining fire resistance rating. And similar to the standard that's used in the US, ASTM E1119 and UL263, similar to the standard time temperature curve that's used internationally, ISO 834 and various others. Individual countries have different designations, but the basic fire exposure is similar, not quite identical, but similar in all of those test standards. It's kind of the grandfather of all of the fire resistance related test methods. So that's time-based. That's a different thing. It's separating one area of a building from another. You're looking at things like temperaturized structural performance, the ability to sustain a load, and flaming, of course, collapse, things of that nature.
I'm just trying to think in terms of, different kinds of materials for curtain wall and how those were originally perceived. Like aluminum versus steel framed curtain walls have been around, for 50, 70 years, leaving the fiberglass, the newer innovations to the side. What was some of the sort of logic of their categorization, I guess?
That's one of the other interesting things that I've been involved with in the code development over the years that has happened. You have to appreciate that in Standing Committee on Fire Protection, whether it's provincial, national, but the concept of cladding from a fire protection point of view, and as you can see, if you look at the S134 standard, it defines, if you will, cladding as everything from the outside of the interior wall, from the back of the interior wall out. So in other words, it's that whole assembly, that system, starting from the interior drywall, working your way out. If you look at other parts of the code from a building science perspective, cladding is the part that keeps the water out the moisture away, etc. So in the early days, when we talked about cladding, we really weren't understanding that cladding was more than the exterior face. So those things like steel and aluminum performed well in and of themselves in the testing that we were doing, or in just an interpretation. Of course, steel being non-combustible. Aluminum, there's a bit of an allowance for, because its melting temperature, I mentioned the 750 degrees Celsius criteria for non-combustibility. Well, of course, aluminum melts at a lower temperature than that. So there's a little bit of an allowance for aluminum.
What is the temperature for aluminum off the top of your head?
I believe it's around 650, 650 Celsius, if I recall correctly, between 650 and 700 Celsius.
Okay.
So, it's just a problem with the test, but you can't actually do it because you'll fail on weight loss, not because it's burning, but because it's melting out. Now, one of the important changes that I advocated for a long time, and it actually took me a long time to somehow convey, that we had a problem in using the word cladding, because under Part 5, being building performance, cladding is perceived, as I said, about the part that keeps the rain out and the wind out. But under Part 3, it meant something very different. So 3155 is the clause in the NBC that S134 is referenced in for combustible cladding. I believe it was the 2015 edition when we finally added 3156, which is for combustible components in an exterior wall. In other words, the stuff behind the cladding. And it loops you back to 3155. So in other words, we now understand without controversy, if you will, you're using some kind of combustible components behind the outermost layer.
Right.
It still needs to be tested.
Is it the 2020 National Building Code? There are now, allowances for combustible sashes of window frames, as long as there's, a certain separation. So, curtain wall could be used in this application, but it's more of a strip window application. My understanding is that the recent testing that was done by NRC and a few, sort of Canadian window manufacturers has made it so that it demonstrated essentially equivalency in terms of exterior flame spread, or in terms of S134 between fiberglass and aluminum. Is that change going to open the door to other kinds of changes in the future? What do you see that, what are the implications of some of that?
That's a good example of understanding and appreciating that our code is objective-based. That's the advantage of being objective-based, as much as it's difficult to use for most people. And in fact, not widely used because it's difficult to use and enforce. From a code perspective, a standing committee or a committee can look at the objectives. What was it trying to achieve? Look at the methods that we have available that we were satisfied have been achieving it, and provide a pathway for something new and innovative to be able to be introduced if it has the data to support it. I think that pretty much is the path that particular requirement followed in order to be justified.
To the American side, because that's a market that we're now more interested in and have now certified, obviously NFPA 285 too. What do you see happening in the US market in that, or the US sort of codes and standard side? And is there a future where we might see actually Canadian and American understandings of fire harmonized in the same way that we have for thermal performance or air and water tightness?
So the US market, the US codes, let me say, the predominant code, of course, being the international codes, series of codes, work on a different basis. So they're not explicitly objective-based or performance-based. They're still traditionally, like Division B of the NBC, they're still traditionally prescriptive in nature. There are obviously performance elements like performance tests that you have to accomplish, etc. But limitations and such are pretty much spelled out. In the case of exterior walls, it's actually, I think, quite reasonably well evolved in terms of the path that you need, what's permitted and what isn't. But it is more prescriptive. All codes, like the Canadian code, as well as the US codes, do have provision, though, for the US, it's called alternative means and methods. Here we call it alternative solutions, but there is a pathway for alternative means and methods. In other words, something that can be demonstrated on a performance basis to meet the intent of the code and the performance objectives of the code can be accepted. Whether it's alternative means and methods or alternative solutions, they're generally project specific, so they're not generic. So really it's sort of case by case. It needs to be justified, and also, the jury as to who's doing who's going to accept the justifying changes in each case. So it's not necessarily a simple path, but it's certainly available.
You see a future where we're going to have a Canadian system and an American system, essentially.
Part of the issue with building codes, and we're seeing it a lot in the last, I'll say, 3 to 4 years, is it's also influenced by societal expectations. So if you'll notice, there's been, in fact, in the current cycle we're in, there's a tremendous push on things related to energy efficiency, climate change. The US is not to the same extent in their codes driving that there. They may be driving it elsewhere, not necessarily driving it to the same extent or in the same way. Government objectives are not necessarily aligned. So it is difficult. If you think about codes as an instrument of policy, it's difficult to see them fully aligned.
Thank you again so much for all of your help this last little while in opening the doors that we were looking to walk through in the U.S. market in particular. And sticking with the U.S. market, NFPA 285, ASTM E2307. How do those sort of translate to what we understand in Canada as either non-combustible or flame spread ratings? How do we understand those in relation to what we're used to in Canada?
You mentioned earlier that the NFPA 285 and the ULCS 134 tests are essentially tests that are measuring the propensity for flame to travel in or on an exterior wall, not behind the exterior wall.
Of course.
But in or on the surface. And when I say in, I mean, obviously burning in the cavity can also be problematic, depending, as we saw with many examples around the world. And so that is part of the criteria. E2307 is different in that what it's assessing, and ASTM E2307, by the way, is the test for perimeter fire barrier systems, or now called in the US codes perimeter fire containment system. And basically that's the joint between the floor slab and the exterior curtain wall or exterior wall. And so it's an assessment that's a little bit different. Although the apparatus that's used is similar in the case of 285, it's the same apparatus that you use in NFPA 285, but you're measuring a different thing. You're actually installing that joint between the floor slab and the curtain wall and assessing that. And so the curtain wall system itself, the back pan particularly, and the US back pan is not very common. So the mullions, etc., that are part of that exterior curtain wall system all become part of that E2307 tested and listed if you're certifying assembly. I will point out that in the 2020 code for the first time in Canada, well, let me back one step. In 2018, in the 2018 edition of the standard that we use for fire stop systems and joints in Canada, which is ULCS 115, E2307 was incorporated into that for those unique perimeter joints. Because of a timing issue, S115 wasn't published at the time when we needed it, the 2018 edition. So E2307, ASTM E2307, is in the 2020 National Building Code as a standard for perimeter joints. So it is a requirement going forward.
Is that kind of on a project by project basis, or is that just, one system is required to have that test essentially?
If you've got a gap between that, that slab and that exterior curtain wall, you're going to need to comply with, depending on the size of the building, of course, you're going to need to comply to E2307. Now, there are, I'll say, more than 100 systems that are already published and available for a variety of different kinds of systems. So there's hopefully a good selection of options, but if not, then some things may need to be tested.
You mentioned spandrel panels there. I just wanted to sort of jump off that point into how they're much more common in Canada. That's a big part of, what makes, I think, testing, our curtain walls our fiberglass frame curtain wall is kind of different than what these tests were originally designed for, right? Because these tests were originally designed for uniform assemblies. And of course, in most curtain walls that we install, they're non-uniform assemblies. What does that interpretation look like, I guess, in terms of, whether it's at the regulatory level or at the certification level or at the architect's level? What sort of understanding is there from, okay, so we tested this one thing, but of course you can't build that, right? And that's not what you would want to build, and that's not what you should build. But we're still saying that they're equivalent from a fire safety perspective. What does that
look right? like? If you talk about ASTM E2307, the perimeter joint specifically, there are a couple of organizations. So first of all, most manufacturers in the US, and I'm almost reluctant to use the term, and I know they're trying to get away from it, they will look at particular instances, if you ask them to, and provide what they commonly call an engineering judgment. So they will sort of do an assessment based on their knowledge and experience of successes and failures, and give in most cases some assurance of whether a system will or won't meet the intent or requirements of the particular standard. There's an organization that I'm also involved with in the US. It's the International Fire Stop Council that actually publishes guidelines for engineering judgments, both for fire stop systems and for perimeter fire barrier systems. And there are also 2 standards at ASTM for installation and inspection of those kinds of systems. So it's a good system in terms of its sort of evolution. It's mature system now.
To sort of wrap things up for today, it's been a very enjoyable conversation thus far. Looking forward, maybe, we talked a little bit about, maybe the US and Canada won't, don't have a future for harmonizing. In the windows and the conversations that you're having, obviously, the kinds of conversation you're having, by the time those get to industry or to market, there's 5 years, 10 years, plus. What are you seeing right now that makes you optimistic for the future of fire safety and environmental protection in North America?
At the same time that turning the codes into more of a policy document may have a negative side, it's also had a positive side, which is a rarity in Canada where we've had investment in the ability to pursue the R&D and to have the staff at National Research Council, for example, in the code section, actually available to be able to do the work that's required to get those things out much more quickly than we have in the past. The other sort of point of optimism, I think, if we can pull it off, is that all of the provinces and the federal government, of course, have signed the Memorandum of Understanding to harmonize to the national code. The original idea was to do that by 2023. I don't think we're going to hit that target, and I have had a little bit of involvement with the activity, but that commitment is there. And if we can do that, then I think that's a big step forward to at least use the resources we have to pull in the same direction.
That would be great to see, because there's such a lag there, right? There's such a lag between that national publishing of a document and the provincial adoption of it. And we've seen here in Alberta so many times, especially the energy code, right? The can just keeps getting kicked down the road because there's so much pushback from industry, and mostly, and not on the manufacturing side necessarily, but developers and these kinds of things. It would be great to see that kind of adoption. So whether it's 2023 or 2025, that would be fantastic to see for sure.
I think that in general, the code development system will also is undergoing and will continue to undergo kind of an evolution. I think a recognition of the fact that it is too slow. It does need to react more quickly. I will say the US system, one of the advantages is a defined cycle. It's basically a 3-year cycle. And at the end of the 3 years, the slate is wiped clean. And if you're still interested in pursuing something that didn't go your way, you resubmit it. Here, we have tended to just kind of keep things in a pot and never throw anything away. And so I think that's also caused a bit of a large drag on the system over the years. And so I can see that our own systems evolving to be a little bit more responsive in that regard.
Well, that's good news, I'm sure, to our ears and to many of our listeners as well. We really appreciate your time today, Tony, for Curtain Wall Conversations, episode 7. Look forward to seeing what comes next. Thanks very much for joining us.
Terrific. Thank you. Take care.
All right. We hope you enjoyed this conversation as much as we did. Be sure to follow us on LinkedIn, Instagram, Twitter, and Facebook to stay up to date on new episodes of this series. Also be sure to check out our Spotify and Apple Podcast accounts, where this episode and others are now available. If you have any questions about our conversation today or fiberglass framed curtain walls in general, feel free to reach out to us via email at info@glasscurtain.ca. You can also subscribe to our blog for all the latest updates, which we'll link to in the description below. Thanks very much. We'll see you next time.